So today what we're going to be doing is we're going to be isolating a variable. And now, unlike what we did last time, we're going to be moving away other terms. Now, this is going to be called what we perform the inverse, which is mathematical lingo for opposite. And that's how we move the other thing away. So let's go ahead and let's kind of get warmed up with a few of these things. Now, if I have two terms that are on the same side of the equal sign, what I'm going to do is I am going to continually draw a line down the equal sign to separate the left side from the right side. Now, if I'm combining two terms on one side of the equation, I look at them as they are. 120 minus 42 is going to give me 78. And that's all that I need to worry about. Now, here's the issue. What happens if they're on other sides? Well, we'll get there. So on the third one, what we're going to be doing again is just another version of this. I am going to be looking at the left side and the right side and say, okay, all my numbers are on the right-hand side. Let's just go ahead and perform the order of operations as we see them. 8 and 7 are inside the parentheses, so we're going to do them first. So go y equals 14 times 15. And another rule, another reminder is that when we see two numbers side by side, I don't see a plus, I don't see a minus, I don't see a multiply or divide. So what I'm assuming is going to happen is what we call distribution, which is shorthand for multiplication. I'm going to multiply 14 times 15. And so I'm going to come over here and I'm going to set up 14 times 15. Multiply my ones, so 5 times 4 gives me 20, carry my 2. 5 times 1 is 5, plus my 2 left over is 7. Then I'm going to move on to my tens. 1 times 4 is going to give me 4. 1 times 1 is going to give me 1. And then what I'm going to do is I'm going to add these two things, and I get 0, 1, 2. So I get 210. So y is equal to 210. So it's safe to say that when we're combining terms on one side of the equal sign, it's pretty straightforward. But what happens like with this one, where I need to combine this 5 and this 17, but they are on opposite sides of the equal sign? Well, I have to approach it a little differently than normal. Now, if I look at the left side of the equation, I have something with 5 too much. And if I want to figure out what that something is, I need to get rid of this extra stuff. And how do I get rid of 5 too much of something? Well, I take it away. So I say minus 5. But in this case, the equation is not balanced. The left and the right are not equal. So what I'm going to do is if I take something away on the left-hand side, I'm going to take it away on the right-hand side as well. This will allow me to cancel these out. And what I'll have is r is equal to 17 minus 5 is going to give me 12. So do we see the difference between what we did in number 1, where I combined them on the same side, versus what I did in number 5, where when I moved it over, I basically have to take it away from both sides. So let's try that again. So if I have 5 too much and I subtract, what happens if I have 15 too little? I want to figure out what t is, but I've already taken away 15 of something. Well, the way that I get rid of that is I add that 15 back in. But again, I need to balance the left and the right-hand side, which means I need to add 15 over here as well. My 15s are going to cancel out, and what I'm left with is t is equal to 115. Oh, I think we're getting the hang of it. Let's try something a little more complex. Now we've got a little bit of both. This is still technically a one-step equation because there's only one step to isolate the x, but there is a little bit of simplifying that we're going to have to do. So if I look on the right-hand side, I have some things that I can go ahead and I can tidy up. I can say, okay, order of operations says parentheses first, so 2 plus 4. 17 plus x is 13 times 6. And then I can go ahead and say, okay, I see a set of parentheses, which signifies distribution, which is a fancy way of saying multiply times everything in here. So I'm going to take 13 times 6. So 13 times 6, multiply my 1s, 18, carry my 1, 6, carry that, 78. And now, here's the first true step. Now what I'm looking at is, now that I've tidied up this right-hand side, that was really just another way to say 78. Now what I need to do is I need to get rid of this 17. Now, if I have 17 more than x, and the only way to get rid of it is to subtract it away. That's going to go away. And what that leaves me with is going to be an x equals 61. Cool. And so we saw how we subtracted the 17. Had nothing to do with the sign on x. It had only to do with the fact that the 17 was a positive 17. That's going to be very important on this next one. So again, if I were to look at this equation as a left side and a right side, I have some tidying up to do over here. So let's go ahead and see what we can do. Let's see, 13 and 37. 37 and 3 is going to make 40. 40 and 10 is going to make 50. 50 minus 10, that's going to be 40. So I have 40 over 5, negative 53 plus a. Actually, I'm going to draw my a's a little different, because sometimes they end up looking like a 9. Okay, so I've tidied up the top. And remember, that's because the top and the bottom both have an assumed set of parentheses. So I simplify everything up top. Cool. 40 divided by 5, that's going to give me an 8. So I have negative 53 plus a is equal to 8. Cool. So that was just a fancy way of saying 8. Now comes the actual algebra. I need to isolate my a. And now, the reason why I pointed out that the 17 was positive is because of what's going to go on here. What many of you may be tempted to do is something like this, where you have a negative 53 plus a is equal to 8. You might be tempted to say, okay, it's plus a, which means I need to subtract that 53. But that is not going to work. And why? Well, that's a negative 53. Do I get rid of a negative 53 by putting in another negative 53? No. I get rid of a negative 53 or a minus 53 by adding it. So I add 53. And if I add 53 on the left, I'm going to add 53 on the right, which that successfully cancels out my other term. So I have a is equal to 61. Boom. So that's a very important distinction. It doesn't matter what's between the two signs. It matters the sign of the number that I'm moving. If I want to get rid of that negative 53, I have to add it. And now the last thing right here. Looks like I have some combining on both sides. So let's go ahead and start with the side with my m. Now I have a number here and a number here. So I'm going to say, okay, what is 70 minus 13? Well, 70 minus 10 is going to give me 60. 60 minus 3 is going to give me 57. That's a positive 57. Is my m still positive? Well, of course, the m hasn't changed. So 57 plus m is equal to what's going on over here. And now that we've combined that over there, let's look at what's going on over here. So what I have is I have 37 minus 20 over 2. Well, 37 minus 20 is 17. So 2 times 17 all over 2. And now, if I multiply this whole number into this fraction, I'll get, let's take a look. I'll get 2 times 17 over 2. In order to multiply, I need to make that 2 over a 1. So 2 times 17 is going to give me a 34. 1 times 2 is going to give me a 2. 34 divides by 2 and gives me a 17. Now, what do I notice from here to here? What's going on? Okay, I have 2 2's and a 17. And it looks like I multiplied 17 times 2 and then I divided it by 2. So do you think it's safe to say that I can just go ahead and cancel these 2's out and say 17 times 2 divided by 2 cancels out and leave me with just the 17? Now this is what we call cross reduction, and that's going to be a very useful skill later on to make fractions a lot easier to deal with, is we can cross reduce. So let's take a look at the last one. So I have m, and I have, again, a positive 57. So how do I get rid of a positive 57? Well, I subtract it. That's going to give me a canceling out over there on the left. So I just have my m variable, 17 minus 57, well, that's going to give me a negative 40. And there we go. So today we're going to be covering our last one-step equations, and actually towards the end, they're not going to really be one-step equations. We're actually going to be kind of into the two-step equations realm. But I think it's safe to say that we can still look at this through the same lens that we have been. Now, one of the most important things is that we're going to understand that powers and roots, or if we wanted to call them by another name, powers are also what we call exponents. And roots, another word that we could use for them, is radical. Now, depending on what your teacher is and what the day is, sometimes teachers flip between each term interchangeably. I myself often go back and forth between the two. So if you hear me mention the word root and then follow it up immediately with radical, I'm referring to the same thing. A root or a radical is going to be a mathematical symbol like this. It's a square root. So if I said, hey, what is the square root of 9? That would be plus or minus 3. So we're going off of this concept right here. And remember, square roots have both a positive and a negative aspect, because if I take positive 3 and positive 3 and multiply them together, I get a positive 9. If I multiply negative 3 times negative 3, I also get positive 9. So anytime we take the square root of something, we give it both the positive and the negative value. We always end up with two answers. That doesn't work the other way. If I take an exponent, I don't get two answers. It's only when I'm dealing with the root. So let's go ahead and let's take a quick look at what's going on. So if I divide my equation in half, I see that my variable's already isolated. All that I have to do is order of operations on the right-hand side. So I'm going to say, okay, 6 squared is going to give me a 36. And 36 plus 1 is going to give me a 37. And I'm done. Now, if you ask yourself, how did 6 squared get 36? Sometimes what we get is we get a student that says, isn't 6 squared 12? Remember, whenever we have that exponent up in the corner, what that is telling us to do is saying, let's write out that number 6 2 times. It's not saying 6 times 2, it's saying 6 once times 6 twice. If I had something like 6 to the 4th, what that would mean is that's 6 once times 6 twice times 6 3 times times 6 4 times. All that exponent does is saying how many times we're multiplying that number by itself. So let's go ahead and let's move forward. The next one, again, I'm going to split my equation in half and say, okay, my variable's already isolated. I just need to perform order of operations on the right-hand side in order to get my answer. So I know my order of operations says do parentheses first. Inside the parentheses, I have an exponent. So 3 squared is going to be 3 times 3. And I know 3 times 3 is going to give me a 9. So 2 times 9. Also, if we remember, a set of parentheses is going to indicate distribution, which means I need to multiply times everything inside there. So 2 times 9 is going to give me 18. Boom. And there we go. So now we've seen both how powers work and we've reviewed kind of how roots work. So let's take a look at an equation that deals with a power. Now, we said earlier that roots and powers are opposites. So if I have an r squared, the way that I'm going to get rid of that is by taking the square root. And I'm going to have to take the square root of both sides. So I'm left with just an r because a square power and a square root cancel out. And if I take the square root of 16, as we remembered earlier, where we get both a positive and a negative answer, the square root of 16 is 4. So it's going to be both a positive and a negative 4. And in fact, if you're curious, mostly you just know how to do it this way, but if you really wanted to dive a little deeper, what's going on here is another way to write this power. So if I have an r squared that I write inside a square root, a different way to write this square root could be to say r squared to the power of 1/2. All a root symbol is a fraction in the exponent. And so we know that half of 2 is 1, and anything to the first power is just itself. So that's why a power and a root cancel each other out. You don't really need to know too much about this, just know that this is mathematically what's happening in the background. All we need to know today is that a square power and a square root undo each other. Cool? So let's do one more, and this is where we get into, these are really two-step equations, but for the most part, because there's an exponent on the variable, we can still treat them kind of like we've been treating the one-step equations. So I want to isolate my variable, which means I need to get rid of that -1. I know I get rid of -1 by adding 1. What that's going to do is it's going to cancel out. So I'm left with a t squared is equal to 100. And remember, we're not looking for the fancy way to do this. All we know is that in order to get rid of a power, I need to give it a root, and it'll cancel itself out. So let's do exactly that. Let's put a root over my power, and poof, that power is now gone. The square root of 100 is 10, and I need to give it a positive and a negative value. There we go. So let's try one or two more. So let's say the variable's on the right-hand side. Nothing changes. I know that that 7 is a positive 7, and if I want to get rid of it, how do I get rid of a positive 7? Well, I subtract it, which means that 7 no longer exists. I now have an x squared is equal to 1. And again, we don't need the long detailed version of how to solve this. All we need to know is that a root and a power cancel each other out. So I'm left with just an x. Square root of 1 is 1, and I give it both a positive and a negative value. So this is also where we're trudging into possibly two-step equation waters. But let's take a look. We're trying to isolate our variable, which also has an exponent attached to it. So I know that because I don't see a symbol between the 2a, there's no plus, there's no minus, there's no multiply, no divide. I know that there must be an imaginary multiplication sign, which means that to get rid of a multiplication sign, we divide. So I'm going to divide by 2. So times 2 divide by 2, they go away. And what I'm left with is an a squared. Half of 32 is 16. And again, I'm not looking for the super detailed version of us walking through this entire thing. I know that the way to cancel out a power is by putting the same root on top of it, which means I'm left with just an a is equal to 4, both a positive and a negative 4. Perfect. Last one. So I'm going to draw my line down the sand. And first I notice I have some things that I can combine. So I get a 5m squared is equal to 70 plus 10 is going to give me 80. Now I'm going to treat this just like I treated the one above it. I don't see a symbol between the m and the 5, so I'm assuming it's multiplication. And the way to undo multiplication is by division. So I'm going to divide both sides by 5, and that's going to cancel out and leave me with just an m squared. 80 divided by 5, well, let's take a look. If I take 5 into 80, 5 goes into 8 once, subtract, carry my 0, 5 goes into 30 6 times, perfectly. So it's going to be a 16. Again, I don't need the super detailed explanation of how to do this. Just take a square root of a square power, and you get yourself an isolated variable. Square root of 16 is 4. I'm going to give it both a positive and a negative value. Boom, and that's it. So today we're actually jumping into our first true two-step equations. This means that in the solving process, we're going to have to do at least 2 of these steps. And today we're basically going to focus on isolating the term and the variable in the correct order. Now remember, we always want to move down the algorithm step by step by step. We want to clean it up by getting rid of parentheses and fractions. We want to make sure we combine all like terms by asking ourselves, is the variable all in one spot? Then we want to move into isolating the term by asking, is the variable alone on that side of the equation? And then we want to end with, let's isolate the variable by asking, does it have a coefficient? If so, undo it via multiplication and division. So let's take a look at what we have today. So what we have today is if I have a 2x plus 1 equals 5, I am wanting to isolate my x. Now my x is immediately connected to the 2. So the first thing that I notice is that x term is not alone. There's something else over there. It's a 1. So what I want to do is I want to get rid of the 1. I know to undo addition, I do subtraction. And I have to keep the equation balanced at all times. By what I do to one side, I do to both sides. This leaves you with the 2x is equal to 4. Once I know the term is isolated, I'm going to isolate the variable by saying, what is the coefficient? Now, there's no symbol between the 2 and the x, so I'm going to assume it's multiplication, which means I undo multiplication with division. Times 2 divided by 2 cancels out, and I have an x is equal to 2. That's it. So let's do another one just like that. Now, remember, I want to make sure my term is alone. So I'm going to say, hey, is there something over here on this side of the equation that doesn't have a y? And the answer is yes. I need to get rid of that 4. So I get rid of a plus 4 by minus 4, which is going to cancel that out. So I'll be left with a 3y is equal to 13 minus 4 is 9. The second thing that I do is I know that the 3 and the y, because I don't see a symbol, it must be multiplication. And the way that we undo multiplication is via division, which is going to cancel itself out. So I know y is equal to 3. Boom. Last thing on this side. This one's going to be a little different. Now, first off, I know that my term's not alone. I need to get rid of this minus 5. When I add the 5 to both sides, I know that they cancel out on the left. So I'm left with my 4r. 21 plus 5 gives me 26. And you might pause to stop here because you're like, okay, I see a problem about to pop up. When I'm looking at this multiplication and I want to get rid of it, and I ask myself, does 26 divide by 4? Well, short answer is no, it does not. So what we're going to have to do is we're going to have to look at the 26 over 4 and say, if I can't fully reduce that, can I reduce it by something else? Can I divide them both by something higher than 1? So can 26 and 4 both be divided by, let's start with the first one, by 2? Well, yes. So what I'm going to do is I'm going to divide by 2 on both the top and the bottom, which is going to net me, let's see, the top is going to be 13, the bottom is going to be 2, and then I'm going to say, can I do it again? Can I do it with anything else? And for this one, the answer is no. That is the most that I can do. So my r is 13 over 2. Let's do a few more. Okay. So this one's a similar setup. I have a 16 minus 1. I know my t term is not alone. I have this minus 1 that doesn't have a t attached, so I want to get rid of it. So I'm going to add 1 to both sides. That's going to get rid of my minus 1. That's going to give me a 6t is equal to 66. Again, I know that because there's no symbol, that must mean multiplication. So I'm going to take that and divide both sides by 6, because times 6 divided by 6 cancels out. And 66 divided by 6 is going to give me an 11. Perfect. Now, the last two are the same two steps, but we're dealing with negatives. So if I look at this one, again, I'm going to go through the steps. I want to isolate my x term by getting rid of the plus 7. Get rid of the plus 7 by subtracting 7. What ends up happening is I have a negative 4x equals, let's see, that is 30 minus 6 is 24. Now, what a lot of students will do when they see this is they see this minus 4 or negative 4, and what they immediately go for is they say, hey, negative 4x equals 24. Let me go ahead and add 4 to both sides, because minus 4 plus 4 cancels out, right? No. We need to look at how is that 4 connected to the x, because if I want to isolate the x, I need to undo how that 4 is connected. And we know that 4 is not connected by subtraction. That's the sign of the 4. It's connected with multiplication. And so we don't undo multiplication by addition. We undo multiplication by division. So I'm going to divide both sides by a negative 4. And that is going to cancel everything out. So we don't want to do this. We want to make sure we undo the proper operation. And the second thing, when I have two different signs, if I have a positive divided by a negative, I'm going to get myself a negative. In fact, any two different signs are going to get me a negative. If I have the same signs, either a positive positive or a negative negative, they're both going to end up in a positive. If they're different signs top and bottom, doesn't matter which way they are, I'm going to get myself a negative answer. Perfect. Last one. When I draw my line down the middle, again, isolate my a term by getting rid of that minus 2. So I'm going to go ahead and add 2 to both sides. What I notice is that negative 52 plus 2, well, that makes it less negative because I'm adding a little something. So if I make it a little less negative, that's going to give me a negative 50. And then again, just like before, we know that that a term is connected via multiplication, which means that I'm going to have to undo the multiplication by division, not by addition. So if I divide, I cancel out, and I'm left with an a term on the left. And if I divide by the same signs, I know, as we said earlier, that's going to be a positive 25. There we go. So today we're doing what I like to call three-step equations. Really, this is our first foray into multi-step equations, but it's always going to be a very consistent flow. Again, we tend to have the four-step process by getting rid of any parentheses and fractions, combining like terms, isolating the term, and isolating the variable. Now, it's these bottom two steps that we're going to be focusing on mostly here today. In future lessons, we'll go through those. So let's go ahead and take a look at how we are going to address everything. Our first step, as always, is going to be to draw a line down the equal sign so we can balance our left and right side. And then we're going to say, okay, if I need to isolate the term, remember, a term is anything connected with multiplication or division. So it's connected with multiplication or division. So that's what a term is. And so I'm going to say, okay, that 3 and that x are connected with multiplication, along with, even if I wrote this out longhand, both x's would be connected. However, this 10 is not. So what I have to do is I'm going to have to get rid of the 10 by adding or subtracting. So the opposite of minus 10 is going to be plus 10. And if I add 10 on the left, I'm going to add 10 on the right. And that's going to allow my equation to stay balanced. Those cancel out, and I'm left with nothing but the 3x squared on the left. Now if I have a 10 and a 7, I either have two options with a negative 7 and a positive 10, negative 7 and a positive 10. Students usually go one of two ways. They either say, okay, I have a negative 17, or I have a positive 3. Which do you think? Well, we're going to go with the positive 3 because the signs are different. And if I take a difference of signs, I know when I add or subtract, I'm going to take the difference between them. Difference between 10 and 7 is 3. The 10's bigger, so I keep the 3. Boom. Now the next thing I want to get rid of is I want to get rid of the 3. And if I remember, that 3 right here is connected via an invisible multiplication symbol. And so how do you get rid of multiplication? With division. And that's going to cancel out that term and leave us with x squared is equal to 1. And now this brings us to what we've learned in one of the previous lessons, is the fact that anytime we have a square power, the way to undo a square power is via a square root. So the opposite is the square root of x. So if I have a square root, they're going to cancel each other out. So why don't I go ahead and square root the square power? Boom. So what that's going to do, that's going to leave me with just an x. And the last thing that we get to is, what is the square root of 1? Well, most of us immediately jump to 1, but there's a second value. If we remember what two numbers multiply to give me a positive 1, let's go back and check our multiplication charts. If I take a positive times a negative, I'll get a negative. And if I flip them, a negative times a positive will also get me a negative. But I need a positive number. Well, there's two ways to get a positive number. Positive times positive, or negative times negative. And so this is what we're looking for. We have two ways to get there. So anytime we take the square root of a number, we get both a positive and a negative answer. And there we go. And so we're going to follow this set of steps a few more times, see if we can come up with any conditions of which might cause us to ask questions. So let's go ahead and let's move to the next question. Again, my first step is always draw a line down the middle, write down the equal sign, and I'm going to identify the two terms. I have a y term and a number. So I need to get rid of that plus 2. And the way that I know to get rid of that is by minus 2. That goes away. I'm left with a 5y squared is 320. So now that I've isolated the term, I need to isolate the variable. And that variable is connected via multiplication, so I'm going to go ahead and divide. What that's going to do is cancel out that 5. Now, I don't know about you, but I don't remember how to divide 320 by 5 right off the top of my head. So I'm going to go ahead and do a set of long division over here. So 320. Well, 5 doesn't fit into 3, but it does fit into 32. It can fit 6 times. So subtract that, I have a 2. Drag down my 0. 5 fits into 20 4 times. Exactly. So what is 320 divided by 5? It's going to be 64. And again, if we remember that a square power and a square root are opposites, how do I get rid of a square power? Well, with the square root. And the second thing that a square root tells me is I'm going to get two answers, a positive and a negative, whatever the square root of 64 is, which we know to be 8. So y is equal to both a positive and a negative 8. Awesome. Now, what happens, might you ask, if I have a negative coefficient? Well, let's go through the series of steps. I'm going to split my equation down the middle. I know I have a term and a term, which means I need to get rid of the 6. And that's going to go away. Now, I have an option here. I have negative 169 and negative 6. It could either mean that that's going to give me a negative 175, or if I look at it and subtract, a negative 163. What do you think is going to happen? Well, that's right. This one is the correct one. Because if I have two signs that are the same when I add and subtract, I go ahead and I combine their values. A negative and another negative make an even bigger negative. This isn't multiplication. A negative and negative make a bigger negative when we add or subtract. So I know I'm going to get a negative 175. Okay. Our next step right here is to get rid of the coefficient. I know there's an invisible multiplication sign between them, which means I have to divide. It's going to cancel out my 7s, and it's going to leave me with r squared is equal to, okay. Now in this case, a negative divided by a negative is going to give me a positive. We're not adding or subtracting, we're multiplying or dividing. So negative and a negative give me a positive. So it's going to be a positive something. Let's take 7 and divide it into 175. 7 fits into 1 no times. 7 fits into 17 twice. Drag down my 5. 7 fits into 35 5 times. So I get 25. Okay. The last step, how do we get rid of a square power? If we remember, powers and roots undo each other. So how do I get rid of a square power? Via a square root. And that square root also tells us that I get two answers. R is going to equal a positive and negative, whatever the square root of 25 is, which is 5. Awesome. So what happens if I have a negative coefficient and a negative term? Let's take a look. I'm going to draw my line down the middle, and my first thing is to get rid of the adjoining term. I'm going to add 2, which is going to cancel those out. Now again, what I've got going on right here with a negative 164 and a positive 2, do you think that's going to give us a negative 166, or do you think that's going to give us a negative 162? Well, we notice the signs are different, so I'm going to take the difference between the two, which means I'm going to get a negative 162. Okay? My next step again, I notice that there's an invisible multiplication sign. I'm going to go ahead and divide it. That's going to get rid of my negative 2. And we know that a negative divided by a negative is going to give us a positive. Let's see, 2 into 162. 2 does not fit into 1, but it does fit into 16 8 times. 2 fits into 2, 1 time exactly. So I get a positive 81. And then the last step, to get rid of a square power, we use a square root. Square root also tells us one additional thing, that my t is going to have 2 answers, whatever the square root of 81 is, which is 9. Perfect. And so I think we've got the gist of what's going on here. The only thing that might get to us is what happens when I don't have a visible coefficient. Well, let's take a look. Nothing too much new. Get rid of your term. Cancel. Negative 61. Actually, I'm going to do that over here in blue. Negative 61 and negative 3. Do we think that's going to give us a negative 64, or do you think that's going to give us a negative 58? Well, you'd be right in assuming that two negatives, when I add or subtract, make a bigger negative. We're not taking the difference because I don't have different signs. So I'm going to get negative 64. And now here's where some of you might be questioning, well, how do I get rid of the negative sign? I don't have a number that I can divide by. don't forget, anytime I have a coefficient that I can't see, I'm going to assume that that coefficient is an invisible 1, which means that I can go ahead and divide by a -1, and that will go ahead and cancel that thing out. And we know that a negative divided by a negative is going to be a positive 64. And so, see, it wasn't too terribly bad when we have a negative invisible coefficient. It's just a -1. So that way we can go ahead and cancel out the square power with a square root, which will leave us with an x, and we know with the square root we get 2 answers, a positive, negative, whatever the square root of 64 is, which is 8. Awesome. Let's do one more of those, just to make sure we got the process down. Divide my equation in half. Let's go ahead and get rid of that non-a term. That 2 doesn't have an a, so I don't want it. It goes away. And what I have, let's see, -51 and +2. That's either going to be -53 or -49. What do you think? You'd be right to assume that the difference in signs means I take the difference in their values. The difference between 51 and 2 is 49. I'm not going to sum them up because I'm not combining them. They're not the same thing. So I get a -49. So I have a -a squared equals -49. Now again, I don't see a coefficient, so I assume that that must mean that there's a negative invisible 1 hanging out right in front of there, just where I can't see it. So I'm going to divide both sides by a -1, which is going to cancel out that coefficient, and I'm left with an a squared is equal to a +49. And my last step, as always, cancel out a square power with a square root, which is going to give me 2 answers, a positive and a -7. There we go.